And that is, if I present to you this box where we've taken a sample, this company has taken developed a new test for screening patients for flu. There's a quick diagnostic test I think now they do in doctors' offices for flu. Fortunately, I've dodged it so far this winter, right? But you never know. Okay, we could get there. Okay, so now let's take a look just from what we have here and see if we can't figure out what the sensitivity, specificity, positive predictive value, and so on and so forth for this test is. Okay, well, first of all, how many people actually have the flu? That's going to be 320 people. How many people don't have the flu out of the patients that came in with respiratory symptoms to a doctor's office that was part of this study? Well, 480. Okay, what's the total number of people? It's equal to 320 plus 480, and that's equal to 800 people. 280 of those people tested positive. 500 and let's see, 520 tested negative. Okay, so it all adds up to 800. What's the prevalence of flu among this population of people that came into an office with respiratory problems? Okay, it's going to be equal to the number of people that have the flu divided by the number of people that were in this study. 40% of the people actually had the flu. Of course, this is a skewed sample because we are only testing people that went to the doctor complaining that they might have it. Okay, what's the sensitivity of this test? Well, the sensitivity of this test is going to be equal to, let's see, it correctly identified 240 people with the flu out of 320 that actually had it. So the sensitivity is 75%. What's the specificity of the test? It correctly identified 440 negatives out of 480 people that were negative. Okay, what's the positive predictive value? Well, let's see. 240 people actually had the disease over 280 people that tested positive total. So the positive predictive value of this test was 86%. If you tested positive, it was 86, probability is 86% you actually had the flu. How about the negative predictive value? Well, it's the number of people that tested negative out of all the negative tests. Okay, negative predictive value wasn't quite as good as the test we did before, but now we have a picture of how good this test is. And we can tell the patient, well, I'm treating you for the flu. I'm going to put you on Tamiflu. I'm treating you for the flu because you tested positive. I'm 86% sure that you have the flu. Okay, so we're at the end of our time, and pretty interesting stuff, right? And some of this stuff, well, the first half, the probability is going to be very important to us as we move on to statistics. The second half of this stuff, the diagnostic testing, is going to be very valuable to us in practice as healthcare professionals, as public health professionals, and as patients, which eventually we all get to be as well. Okay, guys, so we're going to log off. We'll log back on in about 8 minutes onto the lecture section. You should be able to get, if you don't have that, you can always go to Blackboard and you get those numbers there. Good night, and I'll catch up to you guys if you hang around for the second session later. Bye.